we wanted to concentrate a little bit on batteries because this is a question I get asked a lot. Where do batteries play? Batteries, to me, it's a proven technology, right? We use it every day. Data centers, especially, we see it every day. Um, Phones, our laptops. Yeah, I dare say a lot of people on this call today are probably using a device right now that's running on a battery. So, you know, we understand batteries, they're proven, but can they get us to where we need to get us off the grid? That's where we're headed. How do we get there? So some of the newer technologies, nickel hydrogen, which we don't see a lot of, but lithium ion we see everywhere, right? That's the electric vehicles. That's a lot of the devices we use are all lithium batteries. The last battery technology I wanted to talk about, which is kind of exciting to me, is it's called liquid metal. There's a a new company, and it's Ambria, and they are backed financially. Their biggest investor is Bill Gates. So what I was saying earlier about he invests in nuclear facilities, but he's also an investor in batteries. The liquid metals technology is very new. It's definitely in its infancy as well, but it has so many positives that we're excited about. I know instead of using lithium, it uses calcium and antimony, and basically these are inert metals, so they're not flammable. There's no chance of any kind of fire or thermal runaway. And actually, when they're at room temperature, they're solids. And the way these batteries work is once they're delivered on site, they are internally will heat themselves to 500 degrees centigrade. I mean, it's a crazy number that melts the metal. And then they use that for they're conducting electricity. But the interesting thing is it's all contained in the battery. You don't have to provide power for that does it itself internally. And and since it runs at such a high temperature, you can put it in any environment. You can put it in the desert, you can put it in the Arctic. It doesn't matter. So I want to see this happen. Yeah, this is fairly new. Actually work for this client, and it's an exciting technology, and it's something that I see if there ever is a large scale potential for utilities. This is one of the ones I could see being a play for that, and for large solar facilities. Today, it's about Forbes did an article. I think it was Forbes that it's about a third. It's less than a third the cost to buy calcium and antimony than it is to get lithium and nickel and manganese and cobalt. So the cost of to construct these things is going to be a third to a half less. And they're saying lithium ion batteries will probably be down to $100 per kilowatt hour or below by the mid to late 2020s. And this liquid metal thing will actually be significantly less than that. And the other thing that's interesting about this battery is it can do cycle after cycle, and it doesn't degrade like the lithium does. Lithium degrades after the more times you hit it. These batteries actually like to be discharged completely every day or two. And it's really nice to see somebody going outside the box. And I think this has a lot of potential. And since you don't have to heat it and cool it, and you can set it anywhere, it saves you money on the ancillary electrical costs. So that technology is something that we're going to keep our eye on. I can't say that it's a solution today, but it is a potentially exciting solution.